So here we go. Common core today is G for geometry, CO for congruence, and it's number 11, which stands for proving theorems about quadrilaterals. All right, proving theorems about quadrilaterals. So first of all, kites and trapezoids are definitely quadrilaterals because they've got 4 sides. So a characteristic of a kite. So let me just draw our kite again. I'll just try and draw it freehand. Nothing perfect, but you know, boom, 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 boom. So what do we know about a kite? The consecutive sides are equal, but not all 4 sides. So what's so unique about a kite? Well, one thing is that diagonals, right, bisect. No, that's not true. Diagonals are perpendicular is what I meant to write. My goodness, off to a bad start. Diagonals are perpendicular, so if I draw it in, and if I drew it right, which I didn't, they are perpendicular, okay? Diagonals are perpendicular. What else do we know about a kite? Not much, except for maybe one set. So you have one pair of opposite angles are congruent. Not much you get out of it. It's not part of the cool parallelogram family, is it? So it doesn't have much. It's kind of like, you know, that child in your family that, you know, disappoints you, but not as bad as a trapezoid, okay? Because that child has not much going. So that's that child in the family where it's like, okay, seriously, what's so special about this guy? What's so special about this guy? Only one thing. It was just a trapezoid. It just has one set of parallel sides. Okay, and that's it. Opposite sides are not equal. Opposite angles are not equal. Diagonals don't bisect each other. Diagonals are not equal. This thing has nothing special. Okay, so Nate, Kurt, here we go. Now, but if it's an isosceles triangle, then it becomes a golden child. It becomes a child of the family that everybody loves because it has so many unique things. All right, so see if I can find one on here. There is one in here. Okay, I know I have one in here somewhere. Where? I need some new templates. I know I have one. Got it. Found it. It's right there. Right. So, if it's an isosceles trapezoid, then the legs, and they call these the legs, okay? They don't look like legs, but these are legs, okay? Those are the legs, and these are the bases, okay? Base 1, base 2, okay? These are the bases, all right? So what's unique about an isosceles trapezoid? Well, first of all, it does have one set of equal sides, so we know that. It's got one pair of congruent sides. We know that. It's also going to have base angles that are congruent. Base angles are congruent. So that's congruent to that, and this one's congruent to that one. And its diagonals are congruent. Diagonals are congruent. So if I draw my diagonals are congruent. I can draw that in. That one's congruent to that one. Okay. Now, those are all of our characteristics. Let's see if we can do some problems up here, okay? Slide this up. Okay, you guys are good at sliding this up? Am I going too fast? Am I okay? Okay. All right, example number 1. Find all missing angles. Well, I know it's a trapezoid. See the parallel. I know it's an isosceles trapezoid, right? So right off the bat, I'm going to let this side here be also 117, right? Base angles are equal. Now to get these two angles, okay, these have to be supplementary, okay? These two will add up to 180, okay? So if I go 180 minus 117, what's that, Katie? 353? 63. Thanks, Kurt. 63, and this one has to also be 63, okay? Easy, thumbs up. All right, easy, thumbs up, 2 thumbs up, okay? All right, then, example 2. All right, it is a trapezoid, kind of on its side, but there it is, it's still a trapezoid, right? And it's an isosceles trapezoid, so I know the diagonals are equal. So diagonals are congruent, so RT, if RT is 24.1, right? And QP, that's right here, is 9.6. Well, I know the whole thing. This whole QS has to be 24.1, right? So to find just the last bit, PS, I'm just going to go 24.1, subtract 9.6. I need a calculator. Here we go. I mean, I could have you guys do it for me, right? Oh, that calculator's no good. That one's dead.
14.5.
Thanks, Katie. I can always count on Katie. What'd you get, Katie?
14.5.
14.5. Thank you. Okay, easy. Okay, turn the page. Okay. All right, now, what do we know? It's isosceles. What do we know? Yeah, those are equal, right? Base angles are equal. Oh, I got x squared, but that's okay. I can handle that. So I got 2x squared minus 25 equals an x squared plus 24, okay? There with that? Okay, if I solve, let's go minus an x squared minus an x squared. So I'm going to get a 1x squared because that cancels. Minus 25 equals 24. How am I doing? How am I doing? Good? Plus 25 plus 25. X squared equals 49. Square root x is 7, okay? So x is 7, what's the angle? I don't know, let's plug it in, right? 6, 7, plug it in maybe right there. So I'm going to go 7 squared plus 24. So I'll have a 49 plus a 24. Katie, what's that?
73.
Thank you, 73 degrees. So that one's 73 degrees. That one's 73 degrees. This one is 180 minus 73 degrees. What's that, Katie? 107. 107. Thanks, Katie. 107 and 107. Capiche? Seem easy? Okay. I agree. Okay, now, example 4. Okay. Nicole, this one you and I did earlier. We know that this plus this divided by 2 equals the midsegment, okay? So we know 38 plus 24 divided by 2. So to get the midsegment, we're just going to go 38 plus 24 divided by 2 is equal to mn. Okay, it's the midsegment, right? So base 1 plus base 2 divided by 2 equals the midsegment. Oh, Katie, I'm going to just keep asking you. So it's going to be a, what, a 62?
Yes, divided by 2 would be 31.
There you go. Thanks, Katie. 31. Easy? Easy, easy, easy. Okay. Now, example 5 is a little bit backwards. It's backwards, but we can do it. So we know that EH plus 25. So I'm going to go, okay, EH, which I don't know, EH plus 25 divided by 2 equals 16.5, okay? So I'm just going to set it up. I know this plus this divided by 2 equals 16.5. So let's solve. Let's solve. So anytime we solve, we undo it. When we undo it, we do the opposite, right? Anytime we solve, we undo it by doing the opposite. So what we're going to do is this. I'm going to take Nate's phone away from him, and then I'm going to finish this problem up. Thanks, Nate. You got to pay attention, young man, huh? There we go. So, step 1, what are we going to do? Let's multiply by 2, because that'll undo my 2, right? Let's multiply by 2. 33, Katie?
Yes.
Okay. So I've got EH plus 25 equals 33. Right?
Subtract 25.
Minus 25, minus 25. EH equals
8.
8. Nice. Not too bad. I think the hardest thing for kids is knowing what to do right here. But remember, when you solve equations, you always undo it. The way you undo it is by doing the opposite. So that big line is divide, so we undo it by multiplying. Okay? All right. Example 6. So this plus this divided by 2 equals this. So we're going to say x squared plus 6 plus x squared plus 2 divided by 2 equals 4x. Whoa, that looks like a hard problem, doesn't it? Wow, we might even have to factor. I know, the F word. I know, but we can do it. I know, think about it. Functions, factoring, all these things kids don't like to do. All start with F. Anyway, let's get started. We got a 2x squared plus an 8 divided by 2 equals 4x. How's that? You okay with that? 2x squared plus 8. Now, let's make this a little bit easier. Both these terms do divide by 2, right? So how about I reduce it, make it a little bit easier. I'm going to have to move the problem over here, but I'll have now an x squared plus 4 equals 4x, okay? Oh, man, now what? Anybody have any great ideas besides me? We got to factor, but not yet. We're going to. What do we have to do before we can factor?
Move x squared over to the other side.
Yes, but no. How's that? You're totally correct. Katie, isn't that great when you and I come up with different ways to do things? I'm going to move the 4x over. Because I like to factor with a positive x squared, right? I don't like to factor with a negative x squared. It just makes it harder. So if I do that, I'm going to have x squared minus 4x plus 4 equals 0. How's that? Now we got to do some algebra. I know it's scary. Anybody remember how to factor besides me? Go ahead. Sarah, what do you think? Take a stab at it. Parentheses, 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 parentheses. Okay. What times what makes 4? What times what makes 4? 2. How can we also make a negative 4? How about a negative 2 and a negative 2? Would that work? Because negative 2 times negative 2 is a positive 4, right? And negative 2 plus negative 2 makes negative 4. Remember doing that in algebra? Remember factoring it all? Okay, so but we're not done. We're solving. So I'm going to go, okay, x minus 2 equals 0 because I'm going to solve it. I'm going to solve it. And I got another x minus 2 equals 0. But we'll get the same answer twice, won't we? Okay. So if I solve, I'll get x equals 2. Okay, that was a good problem. I like that. That's kind of like an extra credit problem, isn't it? So if x is 2, let's find the sides. Okay, if x is 2, let's find the sides. Slide it back up. All right. So this is going to be 2 squared plus 6, which is 10. You okay with that? This is 4 times 2, which is 8. And this is 2 squared plus 2, which is going to be 6. That's a nice problem. I like that one. Okay, homework. It's not that bad. 4 to 46, or we'll call it classwork. If you don't believe in homework, we'll call it classwork, okay? So, 432. We'll just do 436. I don't know if this is 50, what? What did I have? 50, 432. Probably 53. Yeah, it was 53. There you go. Okay, that is it. Now, it's Friday. Nobody wants to do homework over the weekend, so let's